Okay, Coroneos 100 integrals, number 22. A really interesting question. However, this question requires the formula on the standard integrals, which was in the previous course. Students are given a standard integrals, all right? But now they have removed that formula from the formula sheet. But let's still try this question here. We still have a way to solve this question, but it's a really interesting question. All right, so as you can see, we've got a square root of two things, all right? So x plus 1 over x minus 1. How do we do this question? First step to do this question is, let's just break the square roots into two square roots instead of just writing one square root. Now, once you finish that, we need to rationalize the numerator to form a quadratic on the denominator. That's what we're doing. It's not really like going to rationalize the denominator because we don't want to remove the square root on the denominator. So what we need to do here is we want a quadratic, trinomial or quadratic, expression inside the square root, and that gives us some easy integration skills. All right, so what we are going to do is multiply this function, this expression by square root of x plus 1 over square root of x plus 1 dx. Okay, so once you have that, the numerator just becomes x plus 1, and the denominator, what's inside the square root, is the difference of two squares. All right, now once you finish that, you can break this fraction into two fractions. So you've got x over square root of x minus 1, which now it can be solved using the reverse chain rule. The second one is just going to be integrate 1 over square root of x squared minus 1 dx. And the second one is the one I'm talking about. The formula is no longer in the standard integrals, so we're going to deal with this question a bit later, okay? But now what we're going to do is focus on the first one. How do we integrate the first one here? However, you realize this is just using a reverse channel. So we're going to break this one into, change it into x squared minus 1. Instead of writing a fraction with a square root, I want to change it into a negative power dx. All right, now with the second term, I'm just going to keep it. All right, we're going to deal with the second term later. Okay, let's just do the first one. Now we're going to use the reverse channel. The derivative inside is 2x, so I need a 2x in the front. I have x, so I need to put a 2, and I can put a half outside. So this is the idea. So I'm going to put a 2 here, and a half outside. So we've got 2x, x squared minus 1 to the power of negative half dx. All right, now let's continue work with the first part. We're going to deal with the second part later. So we end up with half. We need to apply the reverse chain rule. So everything inside the bracket keeps the same. We plus the power here by 1, and that gives you power of half. And we're going to find the reciprocal of this half, and I'm putting it right in the front. So that gives you times by 2. All right, so that gives you x squared minus 1 to the power of half, or you can just write on a square root. That's how you integrate it. All right, now with the second term, in the previous course there was a formula. The answer is just equals to ln absolute value x plus square root of x squared minus 1. So this answer is just equal to this. So in the previous course, the student can just use the formula sheet and write down the answer like that. But now it's not the case anymore, okay? So, this question has to be solved using a different method. That's a really hard question to do, all right? So since we already know the answer is equal to that, so we're going to solve using the reverse, solve the engineering process. We are going to times both the top and the bottom of this fraction by x plus square root of x squared minus 1. So this is what you're going to get. X plus square root of x squared minus 1 over square root of x squared minus 1 over x plus square root of x squared minus 1. Okay? So you basically change this fraction into here. Again, if you try to divide the top by the bottom, you end up with this, so you can try your own time. Now, why and how do I know this is the way of doing it? Well, just because I know the formula, so I'm just using the reverse engineering to get to this point. Now, after you finish this, all right, so the next step you do is start to think about what is the derivative of the denominator. So let's just try the derivative of the denominator and see what's happening, all right? d of dx x plus x squared minus 1 to the power of half. If we differentiate that, that becomes 1 plus half x squared minus 1 to the power of negative half times by 2x. So if we keep going, that becomes 1 plus, the half and 2 cancels out, so you've got x over square root of x squared minus 1. Okay, now combining the two fractions, two numbers or two terms together, you end up with x squared minus 1 over x squared minus 1 plus x over square root of x squared minus 1. So therefore that gives you square root of x squared minus 1 plus x over the square root of x squared minus 1, which means the derivative, okay, the derivative of the numerator is just equal to the denominator, so derivative of the denominator is just equal to the numerator's there. So that tells you the answer is just going to be ln absolute value, and you just copy everything down inside. Okay, all right, so therefore the answer will be, sorry, I'm just going to rewrite this part here. So the answer is just going to be the square root of x squared minus 1 plus ln absolute value, and you just take the entire denominator and write it inside the absolute value. And that's it. That's the answer to this question here. Again, unfortunately, the second part, you just have to know what to do now, but I don't think this is going to be even in exams anymore. It's not in the formula sheet. So what you need to understand is about the process of this question, like how do we break this one into two parts, all right? And then we times, we sort of rationalize the denominator, but still keep the square root there by having the quadratic, expression inside. So therefore, we can break down into two parts, and we can integrate it one by one. That's the idea that's most important. Don't worry too much about this integration here. As I said, I don't think it's going to be ever tested. All right, thanks for watching.